I'm here to talk to you about WinSE build and the Windows source and source depot and all sorts of those other things. And you guys are probably wondering what I'm going to talk to you about for 30 minutes, considering everybody's compiled stuff. You set up your make files and you type make, right? You type build, or you hit the little build command in the window and it all compiles, right? And then you're done. You copy your binaries on. Yeah, well, if that were the case, we wouldn't have we have 12 full-time people who are employed just to maintain the source and to do the builds and things, and we wouldn't have all this infrastructure. I wouldn't have a job. So here I'm gonna try to give you guys the quick 30-minute run through of what really takes about 6 months to really get a good idea of. So if you guys are feeling horribly confused, it's pretty confusing stuff and is really intricate, and so just kind of take it easy. Yeah, so here we go. Let's go through this. The source. So the source in and of itself for Windows is pretty enormous and pretty amazing. That for Windows 2000, which is the last one that I could get a number on, it's 20 million lines of code. And so if you just take it and you copy the code onto your machine, onto your dev box, and you type build, you need 80 gigabytes of space just to hold the source code, the binaries, and the final compiled DLLs. So that's pretty crazy. And then to add to that, not only do you have a huge amount of source, but you have 5,000 devs and thousands of testers all wanting to access it at exactly the same time. And so, obviously, we don't just have a big directory that has all the files in it. And, you just kind of copy it, right? You just open Notepad and then you just edit it and then you just copy them all in and everything works. Now we've got something we have everything's under source control, and of course, you guys have probably all dealt with source control of some sort. The server holds the checked-in files. You say, get me the files, and you get yourself your own local copy of the files, and you pull them down, you work on them, and then you check them back in. So we use two different types of ones. We have this old school source control thing, which is called SLM or Slime, and it was used for NT4 in the development of Windows 2000, and it was all right, but it didn't scale very well as we got bigger and bigger. And so after Windows 2000 RTM'd, we switched to Source Depot. And if you guys want to read up on either of those types, those are links to the documentation on both of those different types of source control. Then we divide the source up into projects because we kind of had this the NT source code has just kind of been going since the beginning of NT, and so the way we've divided it up is we've got it by project, which is sort of like OS, and so we have the Windows NT project, we have the Windows 2000, we have Windows XP, and we have Windows 2003, and then each of those projects, of course, you don't want to have the whole thing on one depot because then you have a huge amount of data on one depot, and so it's divided up over depots. And so, if you go and grab yourself a Windows 2003 enlistment, you're going to be hitting a distributed system of 33 depots or something like that. And then each project has its own sort of branches. So we divide it further up because we like to do multiple things at once. So we'll be working on our Windows XP service pack. At the same time, we have to produce QFDs for everybody, hot fixes. So we have these different branches so that we don't stomp on ourselves with the larger changes that we want to make. And I have a little bitty asterisk there that nobody can read and you really don't need to worry about. But technically, what I've said here is not exactly correct because some of these operating systems are actually just branches of the same source. And so Windows XP and 2003 really are just exist in different branches, but that's kind of a technicality. The way that you play with all these, you don't want to have to hit all of these 33 depots, so that we have a neat little tool called SDX, which is a wrapper for Source Depot, the executable, which will run it across all depots, so that when you say, get me all the Windows source, it gets you all the Windows source, and you're happy. So, about these branches that I was talking about, basically, it's just like a copy of the source tree. But I mean, it's not really a copy of the source tree because that would be horribly inefficient, and we wouldn't want to do that. So branches are really just a piece of a depot's namespace that has a defined relationship to another piece of the depot's namespace, which is a really confusing way of saying that it's really just another. You can take source code and you can branch it down to even the individual file. So basically, you're just taking part of your code and you're making another copy of it, another name for it, another way to access it, another way to check it in. And so I'm going to talk about branches for the rest of this talk. And technically, they exist per depot, so that you could have arbitrary named branches across all of those 33 depots that I was talking about. But that would be really horribly confusing, and we don't need to get any more confusing than we already are. And so we have a convention where you have the same branch name across all depots. So when you branch for a given servicing thing, you will branch across all relevant depots. And changes, of course, since we are wise and have a fancy source control system, they're stored as diffs, which is nice. So what kind of branches, what are these branches, what do we service? What we service is Windows 2000, and in Windows 2000 we have one branch, which is beautiful and really nice, and you think, well, that's really easy. Why would you have more than one branch? And out of that one branch we have SP5, and we have SP5 level hotfixes, which install on top of SP4. Windows XP, we're a little bit more confused, and we have Windows XP, and so we have a Springboard branch so that the core dev team can go in and make a huge amount of changes for XP/SP2, because they're going to make so many changes that we don't want. They're going to make so many large changes that we don't want to have to expose the hotfix customers to those changes, right? So we've got a separate branch for that, so that Boeing doesn't have to get absolutely taken down by a shell change that we're going to make in the service pack, by a large change like that. So we have a separate branch called XP/SP2, which we actually do the hotfixes out of. And we have a client, XP Client QFE, which we do the SP1 level hotfixes, when those install on top of RTM. So now you're probably thinking, well, why? What's going on here? There's something fishy. Why do we have two hotfix branches? Well, back in the day when we were doing Service Pack 1, we gave it over. WinSE gave Core said, hey, since this is going to be a huge service pack, you guys are going to do it, and you guys are going to make all these improvements to XP. And so Core went off and they did their own thing. But Core is the Windows Core team is more used to building full products. And in full products, you don't have this problem of really having to track dependencies really, really carefully. And so they didn't track their dependencies quite carefully enough. And so what happens now is that if you take a binary from XP/SP1 and you throw it onto an RTM box, your box won't run, and that sucks. And so we have to maintain these two trees so that the XP Client QFE tree is the one for the SP1 fixes, which hasn't taken all of those service pack changes. And I'll show you all of this a little more graphically when we rush over the branching stuff. 2003, we have an entirely different paradigm for servicing. Of course, we still gave Service Pack 1 to the core team, and so there's another branch for that. But then we have two branches for hotfixes, but we have them for a different reason than we had the other ones for. This one is for a QFE and a GDR one. And the QFE ones are the private level that's where we build the private level hotfixes. The GDR ones are for the security fixes and things like that. Because the complaints that we were getting from customers were, hey, I really wanted you to fix, I wanted you to fix this issue in my TCP/IP stack, and, you gave me 30 private fixes that you made for Boeing, and you didn't test them very well, and I don't want to take 30 fixes. I want the security fix that you guys said you were going to give me. And so we've made these two branches for the two severity levels of the fixes. And I'll go into that a little more later. That's backwards. Now, NT4 is really nice. It's kind of like Windows 2000 in so much as it only has one branch. But, yeah, we've got 6 projects for this one. So, for what we did was we made NT4. And then we said, well, hey, we got to do it for the Far East customers, right? Because we want all those languages. Because, why wouldn't we do that? And so we made those, but we made them in a separate source code base. And then we did terminal server, and that was good, but we did it in a separate code base. And then we did terminal server Far East, and we decided, yeah, well, hey, we've already got 3, well, why not 4? And then we did NEC98, which we only do for Japan now, but it has its own code base, which we only build certain binaries from. And then we have Steelhead, which has something to do with networking, but I'm not really sure. But we've built some binaries out of that when people ask us to. And then we have Crypto, which is another code base, which is the security binaries, the crypto binaries for NT4. And then what this is this is an early build of Windows 2000. And so we take the crypto binaries from there, and then we put them into a NT4 build. And so, yeah, if you ever have to work with NT4, good luck. More on branching. I actually give like a 45-minute talk on just branching and what the branches are. And so, if you guys want to like go in and really, really rack your brain over what branches look like, there's more on branching here. And yeah, you get all the gory details of like horrible things, like what do you do when you have to you want to fork something for RTM, like we're going to have service pack 1, and we want to stop taking all those QFEs in the branch at some point, or service pack changes, right? We want to lock it down because we're going to drive towards RTM, but then you have to have a fork for that, but then we also have to keep servicing, then we have to keep making QFEs, and so you get to these occasions where you have like more branches than you have fingers, and you start to lose track of things. But yeah, if you look at those documents, it'll show it all to you. So now, setting up an enlistment, how do you get access to all of these? For NT4, we have a complicated system, very advanced. You mail Alan back, who is the Uber SE developer. He's the dev lead here, and you mail him, and he gives you access. For Windows 2000, we have a form, which actually that link is outdated, I think. And there's that actually, if you go to WinSE QFE and you look for the Give Me Source Access kind of button, it'll take you to the right place. For XP in 2003, that's done by Infra mainly, and you go to that link. To set up an enlistment, there's different instructions for all of them, but basically you just make a directory, you set an environmental variable, and then you tell the SDX client to enlist you across all the things, and you've got yourself an enlistment. NT4 uses Slime, and it gets a lot kind of trickier, and if you have a look at that NT4 enlistment, it's not quite as clean, but it'll tell you how to set up an NT4 enlistment. That's backwards again. So what do you do with Source Depot? Here's just a rundown. The things you do: you add files, you delete files, you diff the files to see what the changes you made, you edit your files, you see what versions of the files you have, you integrate the files, you see how they've been integrated, you see what files you have open for edit, you resolve the files for any changes that somebody else might have made between you and them, and you can revert to get rid of your changes that you found out weren't so good. You review them, I don't ever use that one. You submit them, and then that puts them in, and you sync, and that's what you always use to get your files. Your regular expression sort of happiness is star matches everything in directory and ... matches everything. But that was kind of a painful run through of usage, but I'm sure you guys all can do usage. So now, if we wanted to just like, you're going to run into a problem where Windows is absolutely huge. And if you sit down and you go, I want to compile Windows, it will take you like 10 hours or something. Like you sit down, and that's on a quad proc machine with about 1 gig of RAM. So you sit down on your server and you say, I want to compile Windows, and you have to come back the next day. And that kind of sucks to be a developer. I mean, you don't have to compile the whole thing just to get the piece. And I mean, what happens if the part that you compiled, somebody makes a change to the public library, and then, damn, you got to compile the whole thing again. So what we have in our build environments is we support the notion of publics for things that need to be linked against other things that you don't want to build necessarily. And so you don't have to build the whole OS. And so the build lab actually checks in a set of libraries to it, so that then you can just sync to that directory and you can get those, and then you can build against those, and things are happy. For Windows 2000, it's a little bit more hokey in so much as we don't keep them under source control, and you have to copy them off of one of our indexing servers, but you can do that, and it's all right. It looks all right. So then you want to compile. The first thing you have to do is set up a Razzle, or a NT4, I guess, uses something called Dazzle, and so you set your environmental variables, you set up your Razzle to compile in, and no one actually has ever been able to tell me why it's called a Razzle. So if you guys ever figure out why it's called a Razzle, let me know. Because I've never, even the people who have been here since NT4 have not been able to tell me that. So you set up your Razzle, which tells you where you want to put your binaries. When you compile it, it tells you like where are all those all-important little text files that tell you where you want to put your binaries when you compile them, and where are the big make files to look for and stuff like that. And then you sync your files that you need, and then you use build.exe to compile your binaries, and the binaries then will be bin placed into your binaries tree on the local machine, which is I'll go into that in just a minute. How does build.exe know how to compile? Well, it uses control files. It has, like, you'll find that in these enlistments you have DIRs files hanging all over the place. You have sources files, and you have make files, and DIRs tells you what directories are, and sources tells you what your sources are, obviously, and make files, yeah, you know what make files do. They tell you what to compile and how to link them. Build.exe has some pretty good documentation that you can have a read through there. So the binary tree binaries. So once you've actually gone through and you've got your enlistment and you've compiled your binaries and it's 8 hours later, you now are looking at them and you realize they aren't going to do you a lot of good because they're raw, meaning they don't have any post-processing. Meaning that if you copied them onto your system, they'd work all right sometimes, but they wouldn't be localized, and they wouldn't be rebased, and they wouldn't be, if you needed binding done on them, or if you needed special certs on it, and you'd have to turn your system into safe mode so that system file protection wouldn't just, wipe them out right away. And so you have all these sort of things that have to happen after you compile, because what you've compiled are typically called privates, which are the ones that you can't give away. And so yeah, now we're going to go into, so what do we do to actually put them on the system? After we build them, we want to use them. So for it to be installed on a system, it has to be packaged. And packaging consists on, as I was saying, post-processing the binary, creating the update.exe package, which is the installer that we're going to use to install the package, signing the package if applicable, because anything beyond NT4 has system file protection, which you don't want it to just get rid of your change once you copy it onto the system. And then there are two types of packages. Obviously, there are hotfixes and there are service packs, and those are the two main things that the official build lab will build, and that if you want to run private builds, you can build them too. So what is this post-processing thing? Well, I kind of alluded to this before, but post-processing is it goes through, and for each binary that you've specified to post-process, it's going to localize it, it's going to rebase it, so it's going to give it a certain address it wants to load in. It's going to bind them if it needs to. It's going to do any sort of special binary munging, because there's some binaries that like to be touched in special ways, like your terminal server stuff likes to have a terminal server cert put on it, which is basically just, I think, tweaking the header of the file in a certain manner. You create your cabs for your service packs, because your service pack doesn't just lay down flat files. It has some things that are like MSIs and cabs that it will only install conditionally, which is a real big pain. But for us to build, we have to reconstitute those. You create your MSIs that I was talking about, and you do your obfuscation, which is you go through your symbols for your your Windows product activation stuff. We go through and we munge the binary in secret manners, and we make it so that it's really hard if you've given the binary and the symbols, you can't really figure out what's going on. We do some other symbol manipulation. We make it easier for people to debug the kernel using the private symbols by putting the type information back into it. We do some various, there are various other little binary specific things, like we have to sign themes, and we have to, there's all sorts of peculiar stuff. But so then once we have these things post-processed, we're going to create one of these update.exe packages. And an update.exe package typically looks like this. And this is what, like if you go to Windows Update, this is what a lot of these you're pulling down are. You have your deliverable binary, which in this case is tcp/ip.sys. You've got your installer binaries, which are in green. You have a catalog, which trusts all the things in the package, particularly the deliverable, the tcp/ip.sys, so that your system file protection won't overwrite it. And then you have some update.vir and update.imp are the control file. Update.imp particularly is like the control file that tells update.exe how to install it. Whether or not, it's a special file that, you have to replace immediately, or whether or not, you want to stop any services before you replace it, or there's anything special you have to do, or where you're going to copy it to. All that sort of happy stuff goes in there. So that's backwards again. Wait, am I still going backwards? Yes, that's no good. Okay, so the official package. Did I miss one? Packaging. Oh yeah, there you go. That'd be good. Thank you. Packaging. What we do for packaging, which comes sort of after the post-processing step, is we assemble the post-processed binaries and dependencies, which means that we gather up all the binaries and we look up in a database which says, oh, you changed this binary, oh, you really need to carry along these 6 other binaries because you did something like you changed an API or something, and now forevermore you're going to have to ship these 2 binaries together, or at least until there's no chance that you could ever run across the one that had the old version of the API in it. But we do that. We generate the INF from a bunch of databases that we maintain. We generate a catalog that trusts the INF and the catalog. We then send the catalog to PRS for signing, and since we don't want just anybody to be able to sign things and for it to be able to say this is officially from Microsoft, we only let the PRS lab actually do the signing and control the certificates. And so at this point, it's actually outside of the build lab where we send these off and we say, will you please sign these for us? And they go, okay, well, I'm going to virus scan them and make sure you didn't do anything really wacky. And then they send them back to us, and they're all signed. And then we create express packages, which are the ones using binary delta compression, which are the ones which don't have any actual payload in it, but instead have a little file that say, I'm going to talk to the server, the Microsoft server, and say, I have these files on my system, now get me the diffs. And so it just downloads the diffs as opposed to giving you the whole files. And so that's what the express packages are. We then have to sign the complete packages. So we take everything up and we send it off to PRS again, which is kind of a bit of a pain because it takes about 2 hours. It takes up to 2 hours to do this. So we send them off again, and that's to get the cert on the certificate on the outside, so that when Windows Update, when you grab it off Windows Update and you actually right-click on the whole package, it goes like, this is a good package and you should feel comfortable executing it because it came from Windows. So then we create a slipstream install, which is the install that for the full product. So you take your service pack, and then you take your service pack and you take your old RTM product, and then you munge them all together using some tools, and then you get a full product install. And then we actually release them and we push them to various places, to the release server, and then the release team can actually pick them up and test them and put them onto the familiar places. So all the stuff that I've been talking about so far can be done sort of on anybody's private dev box. I mean, minus the real signing of it, can be done anywhere. So the official build process, like when you come to the WinSE build team or the core build team for servicing stuff, and you say, I want a hotfix or a service pack, because those are the 2 things we build. We're not just gonna. I mean, the way we do it is we maintain these official build machines. Because even though you would think that, we have it in source control, right? We have everything under source control, and, nobody checks in broken stuff because, you check to see if it compiles, and then you submit it, and you just don't submit broken stuff, right? So theoretically, the build lab should be able to go in and just go, build whatever's in source depot, right? Well, we have so many people doing so many things all at once that we found that doesn't really work all that well for when we have to provide like 24/7 critical situation support for different companies. And so what we do is we maintain these official build machines, which are not just the latest source, but they're even a little step back from that. They have an enlistment to the latest source, and then only when the devs tell us that they've made a check-in and that check-in is ready for us to consume and should be given out and put into the official build environment, then we actually sync it and we execute their build instructions to compile it and get it all ready. So that's what that says. The files on the build machine are not updated when a dev makes a check-in. They are only updated when a build request is made, telling us to sync a certain set of files. So what are these build requests? Well, they check into all the relevant branches, and as you saw, that can be like if I make a server 2000, if I make an XP change, that may be 2 or 3 branches that I have to make a check into. Then I'm going to go up and I'm going to make a request to say my change is now ready to be consumed. And so then the builder will go, and the builder watches the queue and actually says, oh, we got a new request. Now let's go build it. So they compile it and they make sure that in the official build environment there are no errors and nothing freaky is going on. That like the binary, the version number has been incremented, and all sorts of other little sort of sanity checks go on at that time. Then the request is passed to the packager, who oversees that post-processing steps, the post-processing steps that I was talking about. And the packager marks the request as built, and then it goes to BVT, which is build verification testing. And they go and they install it, and they make sure it doesn't blue screen your machine, and they make sure that it's properly signed. And they do all sorts of other little checks to make sure that we're not doing any, build has not done anything obviously wrong in building the package. And so that's really the story of build in like 30 minutes. And so if these are your useful links that you should have a look at. The build page, the help page, which has all sorts of things like my happy FAQ. The core build page has a lot of nice stuff and some good documentation on some of the terminology. They have some really good pages on that. And the core FAQ is pretty good too. And so, yeah, that's your lightning rundown of from Source Depot to the time where you submit your request to the time that we build it, and then we say, here from your run request, here's your 97 potential packages that you could get, because we're going to make you a package for every language, every architecture, and then if you've requested for every OS too. So. Things get complicated real quick, but that's build in a nutshell. So, any questions? Yeah, we have some. We use some pretty big and beefy machines. Oh, the question was what kind of configurations do we have for the build machines? And typically they're like dual to quad proc servers with 512 to a gig of RAM and hefty amount of hard drive space, which we pass around because we have a SAN in our lab, which holds which then allows us to allocate terabytes of data all over the place. And so yeah, the build machines themselves and the build infrastructure is really huge, but you can actually do most. You can compile Windows on any system you want, and it just has enough hard drive space. Really, it just takes a long time. Typically, we were building. What OS do we put on them? typically we build on the OS that we're actually building. So for Windows 2000, our build machines traditionally have been Windows 2000. But since Server 03 was released, we've started using Server 03 for most of our machines. And we really didn't like using XP because it really isn't a server operating system and had some unfriendly sort of things like, it just wasn't really appropriate. But traditionally we did that. Now we're moving to all 2003 for our build machines. Go for it. It's always going to be the devs who are going to make the check-ins, and I think it's actually, correct me if I'm wrong, but it's Test. That Test actually is the one who owns the sort of following up of the porting of the bug. Is that right? I think so. But yeah, it is a developer who's going to make the change and actually check in the code, and then the build responsibility is actually just syncing the changes and making sure that they're consumed across. Well, you will make the dev has to make those build requests are made per project, so that once your XP change is ready, you'll make an XP request, and then we will build you an XP package, a set of XP packages. So, yeah. Is there a way to do multiple check-ins, and how is it resolved when there are conflicts? Right now, the way that people do multiple check-ins is that you check it into one of your branches, and then you integrate to all of the other ones. And so you actually have to call the integrate and resolve command for every branch that you're going to do it on. We haven't got a tool that goes and makes all the changes, just because we've been wary of actually not having a person look at the change when the check-in is made, because it's fairly crucial that we get it right once it's checked into Source Depot. And the second part of the question was what happens if there's conflicts? Source Depot has the SD client has a thing a functionality that allows you to view your diffs in several different ways, and so typically you look at those and are able to make sense of the conflicts and then resolve, modify your change so that there's no conflict anymore. So. BBTs they have a whole list of changes, and I think their website is linked off of the build help page. The question is what BBT tests what are the basic BBT tests that are done when we create a package? The basic tests are for hot fixes. They make sure that the rebasing was done right. They make sure that the signing was done right. They make sure that there are installer entries for all the files that are in the package, and that those seem to be right. What else do they do? They make sure that the package structure is appropriate. They make sure that all the types of packages that are supposed to be there are there. Like if it's supposed to have an express package, it has an express package. They make sure that that when you install it on your machine, it doesn't blue screen your machine. They make sure that when you uninstall it, it doesn't do anything bad. It doesn't hurt your machine to uninstall it, and it doesn't leave anything behind. And when you install it, they also check like the event log to make sure nothing weird went on. For Service Pack, there's some more functional BBT testing going on because they have more time, since you'll typically do one Service Pack build a day, and so you have more time to run a full set of functional tests. So they do more functional testing, and the hot fixes are more spot testing to make sure it's not obviously totally broken. So.
I suppose Windows source code is in C++. So what type of compiler you are using to bring
Yeah, Windows. What's the Windows code what's Windows coded in, and what compiler and what version do we use? The Windows source is in, some of it's in C, some of it's in C++, some of it's in, it's in all sorts of different things. And it's the make files that will call the compilers, and depending on what project, depends on what version of the compiler we have, and the version of the compiler that we're using. The compiler is just the Microsoft compiler. It's the same sort of thing we get.
Microsoft is having C++ compiling 6.0, 2002 and 2003. There are 3 types of compilers. So,
yeah, we use.
Specific compiler is using.
The question is about what version of the compiler we use, and it differs between the different OS. Like we typically don't update the compiler unless there's a good reason to across the OSs. So in the Windows 2001, we used the one that was originally that was the compiler when we were building Windows 2000, and so it's going to be like the version. There's going to be different versions in the different projects. So yeah, you'd have to have a look in what's checked into each of those branches, and it will tell you exactly what version it's using. I don't know them all off the top of my head.
Are we allowed to have, say, more than one setting in one particular setting window? For example, if you might have a setting on a particular component and on a particular window setting. Within the same window, I have two settings on the same component again. It might create a setting conflict.
You mean like you make 2 check-ins to the same file, and then you tell the build lab, right? And then you tell the build lab that you want to build that change. How do we know which one of those changes you really meant to build? Right now in the build lab, we just we assume that you can only sync to current. In the interest of keeping the tree as clean as possible, we say that you'll say like I've changed my file.c, so you'll say, please sync myfile.c, and then we'll sync it to the latest version. And right now we don't support the idea of please sync myfile.c to this change number, which would be more granular and is something that we might be looking into in the future. But right now, yes, we only go to the current version. Who maintains the binary dependent database? The developers own the binary dependent database, and it's actually a flat file, text file database, which is parsed by the build scripts when we build a fix. And it's the developers who, when they make a change, that it is their responsibility when they make their change that if they've introduced a dependency, it has to be noted in the dependency database files that are checked in per project. Does the build team maintain the test source code? In so much as we keep an official enlistment of it, and we can compile build requests for it. Yes, we do.
Suppose after building the package, for some reason it has to call back or recall. So how do you call back to the previous source code, or after syncing, after merging? Like, do you have a backup sync, or how is it?
Well, if the fix itself was actually wrong, then we typically don't go and, we don't go and we don't sync the tree back the way, I don't know. So if the fix is broken, then you have 2 options. You either fix it before you re-release that binary, or you back the change out. But we never say, go ahead and sync back to version 7 of this file and then recompile it, because that would make things even more of a mess. Because then, no, you have to. It is then, it's the dev's responsibility then to either back the broken change out and submit a new build request, or to fix the change and then have a fixed binary be released. So, yeah, that's the way it goes. Do we have a way to find if a check-in has broken the build? Yes, we actually run a lot of monitoring tools while we're doing the official builds, and so we do associate a particular check-in, the particular request with the binaries that are compiled. So we can always track it back to the change that, the last, like if someone says like, whoa, what'd you do to my binary? You broke my binary. We can go back and we can say, no, we got this build request that is associated with this, these set of instructions, and this is the last time that we've touched the binary. So yes, we maintain a database of changes on the official build machines. How much time before a release would we start building? Well, we're pretty much constantly building. It depends on what we're talking about. Like for a service pack, you're always building. You have a build schedule, and daily, or maybe once every other day, you're going to build a version of the service pack to make sure that it's so that people can continue to test it and everybody can work on it. You'll always be building it. When we fork to actual drive for the actual RTM of the service pack, that's done. That depends on the management of that project, and it sometimes is a couple of weeks, it sometimes is a month, it sometimes is a couple months. It depends on how it goes, and it also depends on how many bugs we find in that time frame, because they need reset testing all the time. Hot fixes, on the other hand, are turned around and built, and we're just building those binaries, and so we just crank those out, and we build 7 or 8 of those a day, and so people say it's my binary's broken, give me a fix for my binary, so we build them one in a day, and and that's another reason we do these official build machines as opposed to just clean building the entire time, is so that we can guarantee that we can have a environment where we can really say, they can say, give me a binary now, and we can turn around, and then in 8 hours max, in the worst case scenario, we can have a binary for them. Well, XP is actually the question was, we have 2 branches for XP. We have XPSP, which is the Springboard branch, and we have XPSP2, which we're building QFEs out of. Which one of those branches will be the final branch, and what will happen after SP2 RTMs? What will be the one moving forward? And XP actually gets really, really nasty, because you remember that I talked about how you can't take SP1 level binaries and put them onto an RTM box. Well, the same thing is happening for SP2, right? And so we're going to have to maintain. Right now, we're maintaining this old RTM branch, which only contains fixes, not the service pack fixes, right? And we're also maintaining this other branch, which is the XPSP2 branch, which contains Service Pack 1 fixes and all the fixes that went in on top of it, right? And then we have that third branch, which is the Service Pack branch, right, which is the XPSP, which is the one that are actually building the Service Pack out of. And the problem is that you can't drop your binaries between those branches. So actually, the answer is we're going to keep all of them, and they're all going to continue. And so, depending on whether or not your fix needs to apply to those lower service pack levels, it'll get checked into there, but they'll actually be maintained as separate branches, which is very tricky and inconvenient. But I guess another answer to that is that the XPSP branch will be the one moving forward, but we will have to keep the other 2 around. So presumably, if nothing goes wrong, like at SP5, you will only have that one branch, kind of like what we have for Windows 2000. Okay. Well, I guess that's it then. Thanks, guys.